Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. We're going to start with the next section. Our next section is 12.4, that is the increments and differentials. We are discussing the partial derivative of several variables, and always we are taking the help of our knowledge that we have already developed for the single variable functions calculus, and we use that one and we extend it to the more than variable. Same thing we are doing here, that we are having given a function y equal to f of x. Y equal to f of x, we can have the curve here y equal to f of x, and then we have the point x, and then we have point here y. This point is xy. This is moving along the curve, and the point becomes x plus delta x, y plus delta y. So here x is extended y delta x. We get the new point x plus delta x, and similarly here we get here this point here y plus delta y, and this distance between those two is delta y. So we are having here the new point x plus delta x, y plus delta y. When we want to find delta x, well, it's very easy, but when we want to find delta y, that is going to change with the function. So we can have here our delta x into, we say, the increments. So increments were defined in the variable. We say our independent variable is x and dependent variable is y. Then our delta x here, this we say here delta x. I say this is my x1 and I say this is my x2. So I can define this one as this x2 minus x1. You can see here x plus delta x minus x, they become delta x. So the next is I want to find my delta y. So as I know, this is moving along the function. So the value of this here is, we say, y2 minus y1. y2 is x plus delta x minus f of x. So this is now because y is depending upon x and also changing with the function. So the both concepts are coming inside. So this is the same. We are having the more than one variables, even we are having the dependent variable and independent variable. We can define similarly the change in independent variables and the change in dependent variables. I will tell you about that. Next is the differential. Now differential, we just have the definition of the derivative, and we are going to use that one, differentials. We know that we have the function y equal to f of x, and I say here dy by dx, we can write this equal to f dash of x. The basic definition of the derivative and notation for writing that one. Now I want to find this dy. So my dy is equal to f dash of x into dx. So my differentials are dx and dy. Now here we can see it's my delta x. My delta x is straight. I can write this, my delta x. I write here dx is equal to delta x is independent variable. I want to write my dy. So my dy, I replace my dx by delta x. So these are my equations which I can use the differentials to find the value of the dx and dy, the differential, and here are my increments. When we discuss increment, we say this is my exact change. So increment is my exact change. That's my increment. So this is my delta x and delta y. So when I say the differentials dx and dy, this is not the exact change. We say these are the approximate values, or we say it's the approximate change. We say here approximate values. So these are not the exact change. So delta x is same as dx is same as x, but dy is not same as delta y. When you say delta y, that's the exact value. Here this is not the exact value. So but there's a big difference between these two. We will show with the help of example that how we can find delta x and delta. You have done already in your level 1 of calculus to find delta x and delta y. You know that one. We will going to discuss with the function of two variables. I have discussed already the increment and differential. So when I say the differential, that is my dy, and this dy is the approximate value. When I take my delta y is exact value or exact change. So if I take here in the picture in this graph, then this is my dy, here is my delta y, and then when I take dy, then this is my dy. This is my dy with reference to a curve. So you can see here, there we are having this yellow area. This yellow area is the error, and we can say here we having our error is here, error is equal to delta y minus dy. They are not the same. That's when we have numerical approximation, then we're not going to reproduce exact values, but we have the approximate value, but that's easy to do that one. So inshallah I will explain you that one. Now we're going to discuss the increment and differential more than one variable. I have the function w. My function w, I say this is my dependent variable. W is the function of x and y. My x and y are my independent variable. W is my dependent variable. Parallel to the last discussion, we define our increments. So increments, we say our point xy is moving in the plane to the point x plus delta x and y plus delta y. So change in x is delta x and delta y. So when you say the increment, that means I want to find delta x. This is my new point minus the first point, x2 minus. You can say this is my x1 and y1 and moving towards x2, y2. So I am having here my delta x is x2 minus x1 and my delta y is equal to y2 minus y1. This is my independent variable and this is my independent variable and say it's my increments and the exact change. Now I want to find here the increment in the dependent variable w when my x is moving to x plus delta x and y is moving to y plus delta y. So we say this is the function value at the point x plus delta x, y plus delta y minus fxy. So this I say exact change in the dependent variable and independent variable, or we say exact value. I say exact values are exact changes. So this is the increment. Now I want to find the differential as I've discussed before. So I defined here differentials and we are having differential as in delta x, delta y and dx, dy and dw. Now dx and dy, these are in our independent variables. So as before when it was discussed, we say our dx is equal to delta x and our dy is equal to delta y. Now our differentials, we are having here the interesting values when we are having dw. Now my dw is equal to partial w by partial x dx plus partial w by partial y dy. When we are having one variable, then simply we write f dash of x into dx, or when we change it, we find because dx is equal to x, then the f dash of x into delta x. But now there are two variables, we are having x and y. So get the contribution from both variables. We are having derivative with respect to x first and then derivative with respect to y. Even we can write here, just to rewrite, we can write here this is equal to f of x partial with respect to x into dx plus f of y dy. Same thing, just giving the notation of writing it. Also, you can write here this way as a take as a note, so that this must not be going to mix that one. So here we can write here partial f by partial x dx plus partial f by partial y dy. So these are the changes which are differential. We say approximate changes. We say it is approximate changes. That's our dw, dx, delta x. Now as I said before, the dw and delta w are not equal. They are not equal because one is the exact change, other is the approximate change. So there is a difference between them and that is we call error. The error in approximation, and that is equal to our E or epsilon we say, and this is dw minus delta w minus exact value minus approximate value. You want to find the percentage change, you just divide it by w and multiply by 100, you get the percentage change. I will give you one example for this one. So we take some example where we apply the ideas we have generated for finding the increments and also the differential.